and asking at which point in that do you stop off. Whereas the other one is a whole bunch of things that aren't at all the one you're talking about. Yeah, I mean, they're not in a path from the one you're talking about. Yeah. Okay, so Dresky's got a solution to this, which is to say, well, the puzzle is, what is the magnetosome representing? Is it the direction of the oxygen-free water? Is it geomagnetic north? Is it local magnetic north? I'm just curious, what do you think? Can you put your hand up if your intuition is it's representing direction of oxygen-free water? Geomagnetic north? Local magnetic north? Okay, so I would say the majority think that we fooled the magnetosome, but there's a substantial minority that say, no, the magnetosome was innocent, the magnetosome got everything right. Okay, well, it's hard to do that, it's hard to settle that by intuition. I mean, I don't really see you can do it by direct intuition. Dresky's idea is, well, suppose you start out by supposing it's got two different ways of finding out the direction of oxygen-free water. So maybe it uses light as well as magnetism to indicate to find the direction of the oxygen-free water. So if it's got the magnetosome and it's got a light detector and it's got some structure S, then if we've got the light and we've got the magnetic field as both firing S, then that means that you can't identify S as having as its function to indicate either the magnetic, the geomagnetic or local magnetic north, or having as its function to pick up on the light. It must have something further out as its function. Yep, you couldn't identify it with either one. So the trouble with that is, if you're really going to be difficult about this, then you could say, well, actually all that's going on there is that S is indicating either the direction of local magnetic north or the direction of light, right? That would be the natural way to pursue the original problem. So then Dresky says, well, what we need here is associative learning. If you've got repeated exposures to X in the presence of oxygen-free water, then S will start to fire in response to X. If you've got that open-ended possibility of associative learning, you can't tie this down. You can't tie the structure down to representing any one or any finite number of these pathways, because it can always open up to another one. And that's very intuitive, because there's something about you want the representation to be something that's a reasonably sophisticated organism does, and it's kind of surprising if a bacterium with a magnetosome is already representing. The ability to learn about your environment should have something to do with your ability to represent the environment, and this is a very intuitive way in, that the possibility of associative learning about some distal structure in your environment, that's what makes it representation of that factor out there. So at any one time, you could say, all I've got here is something that responds to either this local factor or that local factor or that local factor or that local factor. But the only thing that's stable over time, as the organism keeps learning, is that all these pathways are coming from that one same external factor out there in the distance. So if you're capable of learning any number of new ways of detecting Fness, then you are determinately representing F rather than anything else. So that's the solution to the solution to the local magnetic north problem. It's a real problem. Yep. That's right, F would be the presence of oxygen-free water. So the presence of oxygen-free water is connected to all these other factors. It's a slightly difficult example because it's not so clear you can learn about the oxygen-free water, because presumably if these bacteria get into the oxygen-free water, they just die. They don't learn anything. But if you think of it as rather being something like the direction of food, yeah, then what you have is multiple pathways to getting you to food, and then you learn which ones, which pathways really are giving you ways of finding the direction of food associatively, and you just learn by whether you get the food or not. It doesn't kill you if you don't get it. Yeah. Very good. Yes. 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 Yeah, that'll be another way to do it. Yeah, you could say that learning. Dresky, I think, is just talking about learning the part of the individual organism, but you could talk about adaptation over time as a kind of learning. Yeah. Adaptation of the species over time. Okay, I think that's about as far as Dresky gets in the article. And I think this is pretty powerful. There are a number of problems with this. One is, it's just becoming clear to me in the course of this class actually, that colour is a very difficult case for causal theories of representation. And suppose you think about how you represent things as red or blue or yellow and so on. Do you have any other way of finding out about the colour of an object than looking to see? I mean, it's all very well to say for food or oxygen-free water. There are lots and lots of different ways you can get onto that. But for colour, the only way you have of finding out about the colours of things is looking. Vision is your only way of finding out about colour. But we don't seem to be, I mean, intuitively, Dresky's problem doesn't arise there. There's no, it's not at all intuitive that we'd say our visual system is only representing what's going on at the retina, or only representing what's going on in the light array. No, your visual system is representing something about the object, the colour of the object. But that's determinate. It can't be explained in this way by the possibility of associative learning. We don't have any associative learning here. We only have our one canonical way of finding out about colour. Somebody can't do it by vision, can't do it at all. Yep. Wouldn't it? Yep.
Yeah, would you say that evolutionary learning?
Yeah, but the individual is not capable of associative learning. And the thing is, it's not whether there's learning here about colour in the first place, it's multiple pathways. Yeah. The key to Dresky's idea is multiple pathways, all homing back to the same factor out there. But there aren't multiple pathways from colour to us. Yeah. Yeah. Yes, right. I think this is not in humans. Sorry? You can hear colour? Yes. Yeah. Right, yeah. Yeah. Okay, yeah. Okay. If you've got, this kind of structure, yeah, with multiple associatively learned pathways to your external factor, yeah, then any one of them can be dropped. No one of them is canonical. Yeah. Your kind of situation is perfectly imaginable. It might be. I mean, you could have someone with very sensitive fingers who could just run the fingers over the surfaces of things and tell what colours they are. But if you dropped vision altogether, then what you'd have would be a system that didn't know anything about colour. These other ways of finding out about colour are really only guides to what you'll find when you use the canonical way of finding out about colour. You see what I mean? Namely looking to see. And if you have that, and if you only have the canonical way of looking to see, and you don't have the ability to use these other methods, your brain hasn't been rewired, you don't actually have that capacity, you don't have these sensitive fingers, then you still are perfectly determinately representing the colour of the object out there. That's the idea, anyhow. I think it would only be a guide to the presence of the colour you could see. Yeah. It needs a lot of discussion. If you think about shape, then vision and touch are equally good ways of finding out about shape. Yeah. But vision and hearing, or vision and touch, are never going to be equally good ways of finding out about colour. Vision is always the canonical way, and it's in its own is enough. There is another basic problem here, which is the notions of right and wrong that we have for representations, for sentences for us, they're being explained in terms of the biological functions of physical states. But when you think about it, there are lots of cases in which it might be biologically adaptive to get things wrong. I mean, I don't know if this is true, but I remember reading a report a while ago of studies of how popular people think they are, how popular other people think they are, and how happy the person is. Yeah, and when you do that, you can measure the mismatch between how popular someone thinks they are and how popular their friends think they are. You see what I mean? Some people think they're very popular and their friends don't think they're popular at all. Some people think they're not popular and their friends think they're very popular. You see what I mean? Yeah. So you can measure the mismatch here between what you think of your own popularity and what your friends think of you. And the basic finding was that happiness is correlated with there being a mismatch between what you think of your own popularity and what you think of your friends, or what your friends think of your popularity. You see what I mean? And that makes perfect sense, right? It could be adaptive to make a mistake like that. I mean, generally, it could obviously be adaptive to be incorrigibly optimistic and think that the future is brighter than it is. Someone told me a while ago about an experiment where they had people play a computer game. And so there's a lot of stuff going on the screen, and you've got a joystick, and you can make some input into what's going on in the screen. And the experimenter set it up so you could vary how much control the subject had over what was going on in the screen. So sometimes the subject got very little control, and all that stuff just happening more or less at random. Sometimes the subject's entirely in charge of what is happening in the screen. And the subject is asked to estimate how much control they think they had in their test session. And there were two things about this. One was that everyone wildly exaggerated how much control they had. Everyone reliably overestimated how much control they had. And you can imagine that, right? You're moving the joystick, you're watching the stuff on the screen, and you're thinking, hey, I made that happen, I made that happen. There was only one group of subjects who reliably got it right about the exact level of control. Can you guess what group that might be? The depressed, that's right. The clinically depressed reliably got it right about what level of control they had over what was going on in the screen. So the general point here is that it might be adaptive not to be depressed, if you see what I mean. This was reported in a write-up called Sad But Wise. And you can see how it might well be adaptive to get it wrong about how much control you have over what's going on around you. You will try harder if you think you've got a lot of control. You may do better. So there's a normativity of biological good functioning. That's normative, all right. There's something evaluative there. But it might not have much to do with the normativity of truth and falsity. Fodor makes this point like this in the thing we're going to look at next. Why should we think of the mechanisms of belief fixation, and whatever causing your system S to go into its state, as always designed so as to deliver truths, rather than, e.g., repressing unpleasant facts? I mean, if there's no oxygen-free water for miles, it might still help a bacterium if its magnetosome occasionally falsely indicates the presence of oxygen-free water, right? Because then it will keep trying. Yeah, well, you see what I mean. And certainly something like that might be true for us. There is no guarantee that the kind of optimality that teleology reconstructs has much to do with the kind of optimality that the explication of truth requires. Yeah. So biological functions are normative notion, all right, but it's not obviously the same normative notion as truth or falsity. What's adaptive is one thing, and what's right or wrong is another. So the adaptive value of a representational system might actually just be in producing illusions. There is a final really basic problem for this kind of approach to representation, which is the way that the notion of need is really basic to it. The notion of need is what's anchoring the whole thing, right? Because we've got indication that doesn't of itself do the work, and then we've got function, which mustn't be just what someone intends or wants. It's got to be something about what the structure is doing for the organism, what the structure is getting the organism. But if your whole system of representation is defined entirely in relation to the needs of the animal, then all you can be representing are aspects of the world that relate to your needs. And Gibson, actually, the great psychologist Gibson, seems to have thought that that's actually the right result. He talked about the affordances of an environment, and an affordance is just something about the threats and opportunities that the environment provides you with. So a coffee cup provides drinking, a computer provides typing, a chair provides sitting. Yeah? All the threats and promises in the environment. The affordances of the environment are what it offers the animal, what it provides or furnishes, either for good or ill. And there's another classic definition of affordance from Mark. An affordance is the functional utility of certain environmental objects or complexes taken with reference to individuals and their action capabilities. So the affordances for one species will be quite different to the affordances for another species. Oxygen-free water will afford continued life and sustenance to the bacterium. So what the bacterium is picking up on is the affordances of the world around it. Right? In general, animals are very, very practical. They only care, they only represent what matters for them, for their needs and purposes. The trouble is that with humans, human systems of representation seem to go way beyond just representing what's there for our needs and purposes. Of course we can do that. You can see there's something there that affords eating and so on. But when humans are talking about what happened in the Big Bang, or what's going on 5 miles below sea level, humans are not talking about anything that's defined in relation to their needs. That's a very narrow subset, actually, of what we do manage to think and talk about. We seem to think and talk about the way the world is objectively, the way the world is independent of our own needs. I once was visiting at a psychology department where they had a big car parking structure with, on the side of the car parking structure, it was kind of honeycombed with big cutouts, if you see what I mean. Big cutouts like this, in the side of the car parking structure. And when the structure was built, people just viewed it as yet another horrible concrete thing. And what nobody had expected was that pigeons locally would find this just a wonderful spot for nesting. So they were all occupied by pigeons nesting. So there were affordances there that the pigeons could perceive. They afforded nesting for the pigeons. What humans get is not just, I mean, if we could only represent the things in our environment that were of some use to us, that offered opportunities or threats to us, we wouldn't be able to see what the pigeons saw in this. Do you see what I mean? They would see their nesting potential, we would see our car parking potential, but that would be it. And our representation should just be blind to what the pigeons see. And as we say to the pigeons, I don't see what you see in that structure. Yeah, because if we're only getting things defined in relation to our needs, and they get in relation to their needs, but that's not what goes on. If you just think about that very simple case, we can represent what's objectively going on, the shape of the thing, independent of our needs or the pigeons' needs. We can get something more fundamental, the way the world is in itself, and then we can think about how different sets of needs might exploit that aspect of the objective world. So we seem to transcend in our system of representation anything like this kind of tie always being back to stuff defined in terms of our needs. Okay, on with Fodor on Wednesday.